Here's a quick look at the Tornado's assignment. What you'll do is you'll come here and go to each of these links and answer the questions that are asked on each one. For example, the first one is describe the Fujita scale in 1 or 2 paragraphs. And here are a couple of sites that you can look at. Or you could do a web search, either using Google or your favorite search engine, to get some more information on the Fujita scale. Actually, this one had an update to look at the enhanced Fujita scale. So this did require a web search and summarize that. The Fujita scale was modified in the year 2007, and so just a little update on that. Most of these are fairly self-contained, and the questions and answers pretty much go together. Okay. Now you're supposed to type up the questions and then include the answer with each question. One thing I did want to talk about that seems to puzzle a lot of students is this thing here when we look at tornado measurements. Often the way we measure tornado wind speed and intensity is using Doppler radar. And here's a Doppler radar image. The scale here is in meters per second, and if you multiply that by about 2.2, it would get you into miles per hour. So 60 meters per second is roughly 130 miles per hour. That's pretty fast. But what this shows in the purple is the wind speed moving towards the radar station. The radar station is where all of these lines would meet. The wind speed moving really fast towards the radar station at roughly 60 meters per second. And then right over here, the wind speed is moving very fast away from the radar station at 60 or 70 meters per second. Okay, this is characteristic of a rotating air mass, rotating very fast, or a tornado. Now, Doppler radar cannot measure these tangential wind speeds that are perpendicular to these lines, these radial lines out. It can only measure speed directly towards or directly away from the station. And so this is the characteristic Doppler radar signature of a tornado. The distance scale on the horizontal is 1 kilometer here. And so this looks like it may be 300 meters across or something like that. 1,000 meters is 1 kilometer. Okay. Then the other radar signature that we'll look at is the conventional radar, where you're looking at just the reflective strength. So here you can see the dust and debris, possibly some rainfall, but primarily dust and debris that's been picked up, giving you a very strong reflection. And this captures the full donut shape of the tornado here. The reflection strength is usually measured in decibels. But again, conventional radar measures the reflected intensity of the radar wave and converts that to how much stuff is in the air. And the other thing that some people have had questions about in the past is on this graph. This is looking at a vertical cross-sectional view of the tornado, the same tornado. Again, this is the Doppler radar, so this is the wind speeds. And this vertical axis is the kilometers above ground level. AGL stands for above ground level. And so you're supposed to look at this and estimate the height of the tornado the best you can. And there's no set answer, but you should be able to all agree within a ballpark of each other. Okay, good. I think everything else will be pretty clear to you, and you should be very successful with this. Good luck.